Welcome to this instructional video for tree supports, looking at cable brace systems. My name is Anthony Price, arboricultural consultant and instructor at Tree Life. Before we start, I will outline the different types of tree support that we see used today before presenting a mix of slides and video taken in the field. So the different types of tree support that we see today. I've listed 5 types of support here. Not all are recognised by the British standard, but we'll discuss them anyway. I'm not including supports for establishing newly planted trees in this video, as it doesn't concern this. So here's a brief overview. Props, using wooden or steel props, or even a mound of aggregates. Now, these are suitable for supporting low-level branches or even whole trees. Guys, well, using steel cable or a textile rope anchored to the ground away from the tree. These may be suitable for securing whole trees, although not commonly used, as there's some inherent issues with these. Straps, using steel bands around the stem. Well, these are particularly ugly. They're not recognised by British standard, but may be used to reduce the risk of extensively hollow stems failing. Only really suitable on trees of very limited growth potential, though, for obvious reasons, and such as ancient veteran trees, perhaps, where the crowns have largely gone, and preserving the standing habitat value of those trees. Rods, using steel bars with threaded ends through one or more stems. Well, these again are suitable for stabilizing hollow stems, but also confirming a successful bond between two stems as they graft. It could also be used in conjunction with other supports, stabilizing weak stems and forks. And finally, the focus of this instruction is cable bracing, using either a textile rope. These allow for a bit of stretch, dynamic movement in design, or steel wire with no stretch at all. Their installation can be invasive or non-invasive. In the following slides, I will discuss in what circumstances the use of a support system is appropriate, what constraints and limitations there are in their use, installation principles, component parts of a cable brace system, and long-term management considerations. To install or not. The most common reason for installation is as a control measure to reduce a risk of harm from a defective tree. A common example of such a situation is mitigating the inherent problem of a compression fork failing. The likelihood of failure from other types of defect and features of trees may also be reduced, such as weakened branches due to cavity formation. It could also be a better alternative to removing a tree or branch so as not conflicting with other management objectives of a site use. For example, pruning is not always wanted in response to these defects, and pruning alone may not be sufficient to mitigate the problem. Should special trees with a high amenity value have such a defect, they could be lost without this safety measure. Their integrity, structure, ecological value, and appearance in the landscape could be retained for an extended period. There is a more obvious reason, to the layperson anyway, to prevent the part detaching from the tree altogether. Reasons against installation. Some people do fear trees generally and may feel they need remedial work and additional support regardless to condition. Installation in these circumstances is an obvious no. Installation is not at all suitable on young trees that have not reached their full potential. The tree's replacement would be more easily justified. Installation of systems is, after all, very costly and aimed at older trees with significant defects. Where the likelihood of defects failing can be mitigated by pruning alone, a system should be avoided as the impact on the tree's morphology and biomechanics is significant. That is, that the loading on the tree's structure has developed over many years, and should the load then be taken by a support, be diverted elsewhere and to a different extent, then the tree will stop laying down as much wood as it once did, so relying on the assistance of that support. This means that once installed, the system must stay. Management is a major issue and one that results in the avoidance of installation. It is costly in time inspecting, adjustment and replacement, needing a commitment beyond current budgets and ownership. Finding an experienced and qualified arborist and operative to advise on a tree's suitability for installation and future management is challenging. Without these expertise, it is a non-starter. Aesthetics can be quite questionable and a matter of debate, depending on the site design and usage. In conclusion, there are two reasons to install: health and safety, or to prevent the tree falling apart. And should good management not be guaranteed, then a cable brace should not be installed. Principles for installation. So, hypothetically, the choice has been made to install a system, and now we need to look at the principles of installing that system. For the purposes of this, we're going to discuss the non-invasive method of fixing the system in the tree. First and foremost, a well-planned design is required. This design needs to be educated by the competent arborist who has knowledge not only of the tree's growth characteristics, but also the system itself. The system should be designed to help prevent excessive movement of a weak structure, and in the event of failure, it should have sufficient strength to support the detached part of the tree. Attachment of a system to the vulnerable branch or stem should normally be approximately 2/3 the distance from the union to its end. This can be more challenging than it sounds. The angle, for instance, the angle should be attached so that, as far as possible, it should minimize the stresses imposed on both the tree and the system. The stems or branches should be strong enough to withstand the maximum loads transmitted by the system and not be in decayed or damaged wood at the point of attachment. The vulnerable branch or stem should not be displaced from its resting position, but when the restrained part of the tree is at rest, the cable or rope should not be visibly slack at any time of the year. Cables or ropes should not rub against each other or against fixings or any part of the tree. Securing belts and slings should be positioned and constructed so that they do not slip or cause abrasion or constriction of maturing stems or branches. Remember, we're not rigging for removal here. Where used to restrain and support a structurally weak branch, a system should be designed to reduce the probability of failure, not to replace the support of the branch in its entirety. The natural position of a branch to be supported should not be altered to accommodate the system, and the time of year will clearly have a bearing on where that branch is at rest. Aesthetics, longevity of suitably designed components are equally important. Altering where the load is carried and imparting new and more amplified loads is a significant risk, which takes a great deal of expertise to design a suitable system. So, such systems may well be more damaging if implemented wrongly. Components for non-invasive systems then. Well, ropes may be textile or wire. With wire, we require fixing such as grips and thimbles. And for the rope, well, thimbles may be utilised, but the grips are not required as the rope can be spliced into the tree. A rubber shock absorber can be incorporated with the hollow cord textile rope. And straps are certainly required for the steel wire, but again, not necessarily required for the rope, although ropes can be installed using straps. A steel ring can be utilised to avoid rubbing on a part of the tree, but also to redirect a load. For invasive systems then, well, all but the straps may be utilised in an invasive system, and it's the attachment that changes. And for lighter loads, a scaffold screw eye can be utilised, and for the heavier loads, a threaded bar with ancillary washers and locking nuts. So the steel components are readily available to the ARB industry, while the textile components have been manufactured and repurposed for this use. It is vitally important that the materials used are designed for this purpose. So the British standard BS 3998 suggests that the materials should have a life expectancy twice that of the inspection period. So now we've installed a cable brace system, we've committed to its management going forwards. What's required? Well, first and foremost, we need to have access to a qualified arborist. Now, should the continuity of good management be broken due to the lack of one being available, or perhaps a change in ownership or management, for instance, then the system may become neglected. Remember, the tree will live much longer than the components of its tree support system, so regular inspection, adjustment and replacement will be required. The default inspection regime for inspecting these systems is annually from the ground and aerially within a 5-year period. And this should also take account of manufacturers' recommendations and, well, weather events of biotic and abiotic impacts that may also impact on the tree. So in conclusion, the values of installing a tree support system are clear, i.e., where a tree would otherwise be lost or its crown require more extensive pruning in response to an unacceptable risk or failure. The decision for such remedial work, though, must be made by a suitably qualified and experienced arborist, and that the tree owner is made aware of their responsibility to continue with the tree's costly management program thereafter. I hope you've enjoyed this instruction, and thank you for listening.